Hey loyal fans! This video covers two topics: SolveSpace, which is a CAD/CAM app sort of like FreeeCAD, but much better, and a Python environment called CadQuery, which I think is a better design tool than either SolveSpace or FreeeCAD. But a digression about FreeeCAD. I think FreeeCAD will eventually be awarded the title of worst CAD/CAM program ever written. In my opinion, using FreeeCAD is like eating tomato soup with chopsticks. It appears to be working, but eventually you discover you're using the wrong tool, or you starve to death. I suspect that FreeeCAD has its present problems because its authors kept adding new features without fixing problems with old features, and adding new ways to do the same thing, so that newcomers find themselves confronted with scores of features and no way to discover which features work with other features and which features just don't work. Well, enough about FreeeCAD. People may want to watch my earlier SolveSpace tutorial, link in the description, to cover some of the basics. This video moves into more advanced and powerful features of SolveSpace. Because this video includes SolveSpace tutorial sections that may seem slow-paced and excessively detailed, I ask that viewers feel free to skip ahead to more interesting content using the index at the bottom of the display. I especially encourage viewers to watch the CadQuery section, which reveals a shockingly effective approach to computer modeling, much more efficient than SolveSpace if you're willing to write some elementary Python code. On that topic, don't be intimidated by Python programming. Consider that 20 years from now, everyone will be out of work, replaced by robots, except people who tell the robots what to do. And Python programming is easy, much easier than other computer languages. Okay, let's take a look at SolveSpace. Before my SolveSpace tutorials, I want to cover some basics. Computer graphic design is all about space dimensions, usually 3. Before the era of computer design, there were 2 dimensions, x and y, as in this chart, which might appear on paper in an academic journal. The x dimension ran left to right, the y dimension up and down. When computer design became a thing, when computer displays became the norm, this paper chart scheme was expanded to 3 dimensions labeled x, y, and z. But people, being irrational and mischievous, switched 2 of the dimensions. Unlike the paper chart days, x is left and right, z is up and down, and y is near and far. It's important to remember this to avoid confusion about the layout of these dimensions. In this clip, I show 3 drawing surfaces, or planes, much as they appear in SolveSpace. Using a method I'll show later, SolveSpace lets you choose any of the 3 planes. In models destined to be 3D printed, it's important to choose the right drawing planes so you don't have to rotate your model in your slicer program prior to printing. About the topic of dimensions, here's a useful word: orthogonal. Orthogonal. In the context of computer design, 2 or more independent planes are said to be orthogonal, meaning entirely independent of each other, such that position changes in one dimension don't affect the others. I wanted to show this word because it saves a lot of time compared to planes that are at right angles, therefore entirely independent. Hey, we can't do without certain words that save time and effort compared to alternatives. Here's another example: Schadenfreude. It's from the German. It means taking pleasure in the suffering of others. And get this, there's no substitute English word. The German word is much shorter than its definition, and there's no alternative. But I digress. In the viewer correspondence after my first SolveSpace video, people asked for a tutorial on pipe creation, including bends. So that will be my first tutorial in this video. I also show how to save dimensions created in one group for use in other groups. This is how we get around the absence of globally defined variables in SolveSpace. This section is a SolveSpace tutorial about pipe design. If this isn't your interest, please skip ahead to the CadQuery section later in the video. It's pretty interesting and represents an alternative to graphical design methods. And watch this tutorial subtitles for guidance. Even though I like SolveSpace and use it for small projects, I'm basically a programmer and I prefer coding to drawing. This section is about CadQuery, a free open-source Python library that understands computer design and turns a user's code into models. If you ever only create one computer model with one size, a graphical environment will work for you. But if you want to fine-tune a model or use a single model as a prototype to be scaled to different sizes, then programming is the only practical approach. And don't be intimidated by Python programming. It's easy to learn and pays big dividends in the world. Just remember, after the robots take over, only people with technical skills will have jobs. Here's an example of a CadQuery project that generates a simple cup. Because this video is meant to be an introduction, I made it as simple as possible, the fewest lines of code. CadQuery certainly helps. It lets you write simple, easily understood Python scripts. See the highlighted line? It creates a cup by adding an outside cylinder to a handle, then subtracts an inside cylinder. What could be simpler? And here's the result. Not the most sophisticated cup design, but easy to understand. In SolveSpace, establishing a cup's volume can be tricky and requires experimentation. Here, the user enters the desired cup volume and the program does the rest. Here's what the cup looks like in the programming environment, and here's how it looks in a nice graphics program called Blender. I only recently found out about CadQuery, and I have to confess that I'm now divided. Every project I created in SolveSpace is easier to create in CadQuery. And some of my more complex projects like machine hardware are much easier to carry out in CadQuery. I can write a single CadQuery bolt design script, then submit a range of machine bolt sizes to it without having to change the code. SolveSpace can't do that. Here's another CadQuery demonstration project meant to show how little code and effort is required to produce useful results. This is the CadQuery equivalent of the earlier SolveSpace compass rose, a student-level project to show cardinal directions in 3-space. Notice how little code is needed to create the rows. This project uses the CadQuery assembly feature, which allows combining of elements, each with a label and a color. And Blender knows how to read and render the special file this program emits, including the assigned colors. My purpose with this example is to show how much simpler this is than an equivalent SolveSpace project to get the same result, and it has all the advantages of a Python program. I can change dimensions and colors much more easily than in SolveSpace. Regular visitors and subscribers know I tend to get philosophical as my videos wind down, and that time has arrived. This video is about SolveSpace, a free open-source program, and CadQuery, a free open-source Python library. I write scripts for narration using LibreOffice, free open source, and I record narrations using Audacity, free open source. I edit my videos using Kdenlive, which is, wait for it, free and open source. My computers all run Linux, free and open source. Don't get me wrong, there's nothing wrong with programs you pay for, and capitalism is better than the alternatives. History proves that. But free programs are often the best choice. Free programs are often written by people so good at what they do that they no longer need to make money, but they still like writing programs. Some write programs as a public service, or as an intellectual challenge, or both. Free programs put pressure on commercial software developers to work smarter to justify the cost of their programs. Most people understand the point of free software. Users who can't afford commercial software, and companies like Microsoft who expect to sell you a program whose real purpose is to show you advertisements. Both must face the fact that there are free alternatives. One closing anecdote. During my solo world sail, I visited the east coast of Africa. In one of the cities there, I met another American. We shook hands and, while looking across a vast desert, had a conversation about the state of the world. Then he mentioned that he was in the Peace Corps. I said, wait, You're in the Peace Corps? Yep, he replied. I thought for a minute and said, Can I shake your hand again? You will find links in the description for resources related to SolveSpace and CadQuery and other things, including a link to my free World Sale book. I wish you all the best, and here's my favorite way to end a video.